Hello everybody, welcome back. Today we're going to be doing a problem on electric fields. And this problem reads that a particle has a charge of negative 4.75 nanocoulombs. And first we need to find the magnitude of the electric field due to this particle at a point that is 0.33 meters directly above it. So I've already set up a little drawing here so we could visualize it better, where the test charge P is 0.33 meters above our negative charge, or Q1. And we can see that Q1 would attract this P, since P, our test charge, would always be positive. And in this case, we're going to be using the formula for electric field, which is E is equal to, let me change this to, that's the actual formula, K times Q over d squared. So for this one, if we're just finding the magnitude, we can just plug in numbers. I'm going to move k to the numerator now and say that 8.99 times 10 to the 9th times 4.75, it's nano, so it's going to be 10 to the negative 9th over, what was it, 0.33 squared, and this would give us our E. So we can just solve our first step here. We can cancel these out and get 42.7, and then 0.33 squared is 0.1089, and this would get us around 392. Yes, and this is the SI unit for electric field, or magnitude of an electric field. So that would be our answer for A. That would be the magnitude from that distance. So for B, it's asking us to find the direction of this electric field. And when we're looking at it, I think I already said it earlier, but we can see that since P is positive, it's going to attract to the negative Q1. So we could say that this test charge would move downwards. Downwards on the y-axis, right? It would be going in a negative y direction. If we had a graph here, right, and we're x and y, it would be moving downwards, right? Pretty simple. And then C is, at what distance from this particle does its electric field have a magnitude of 12.0? So we know that we are looking for the distance. So now if we can recreate our little drawing that we had earlier, we could say that this particle is there and Q1 is over here, right? Q1 is equal to negative 4.75 nanocoulombs, and this is P. So now we need to find the distance, where we don't know, but we do know that the magnitude is equal to 12.0, right? And include the SI unit. So all we need to do is kind of derive our equation a little bit to find our exact distance. Here I'll write D because I've been writing D. So we can do a little bit of switching around here and get D is equal to KQ over E, and we'll take the square root of that because D is squared, right? And now we could just plug in again, just like how we've been doing, and we could say that 8.99 times 10 to the 9th times 4.75 times 10 to the negative 9th. It'll extend our square root a little bit, 12.0. Now we have our electric field, so we're plugging our electric field and not the distance, right? And this, we've already done this before. This was 42.7. over 12.0, and 42.7 would roughly be around 3.56, and we'll just take the square root of that, 1.89 meters. So our final answer for C is going to be 1.89 meters, and now we can fill in our distance on our little visualization here. It would be equal to around, D is equal to 1.89 meters. And that is the distance from the test charge to the negative charge, and that's the last part of our problem. Just to recap, now that we've solved our problem, so for step 1, all we're doing is plugging in numbers into our electric field formula to find the magnitude, and that would give us 392. And then for B, all we're doing is looking at our visualization and seeing how the charges interact with each other. We can see that P is our test charge, which would always be positive. Therefore, it's going to move downwards towards our negative charge and be attracted towards our negative charge. And then for C, all that changes here is that we're looking for D, or the distance between the two, right? We're looking for the distance, and then we would change our formula so that we can find the distance, and that would give us the square root of K times Q over E, right? Which is our magnitude. We're plugging in numbers and solving.